We are batch number 1 and our project is implementation of XBEE based data acquisition. Our batchmates are here, and here is the XBEE based data acquisition system. This is the microcontroller and this is the XBEE device. It is a trans receiver, that is, it can be used both as transmitter as well as receiver. It will transmit the data to the another XBEE device placed somewhere else, and that receiver will receive the data and should be connected to the PC using USB. These are the sensor modules. This is the relative humidity and temperature sensor and temperature sensor schematic, and this is wind vane schematic, and this one is anemometer schematic. This is the data acquisition board. The microcontroller which we are using is ATmega8. It is having 28 pins. These are the input pins for the microcontroller which will sense the data from the sensors. This is used to get the data from the 1211 sensor. This is used to get the data from anemometer, and this is from wind vane. Coming to the sensor modules, 1211 humidity and temperature sensor is as shown here. This is the humidity sensor, this is the temperature sensor. It can be interfaced to the microcontroller using two patterns. One is serial peripheral interface and another is serial interface. Here we are using serial interface. In the serial interface, we will use only 3 pins. One is supply voltage, ground and transmit data pin. It can be connected to the DAC board using one 2-pin wire and one 1-pin wire. It will send the data in the particular pattern as shown here. First it will send new line character, then temperature, followed by space, then temperature and return carriage. Coming to the next sensor module, which is anemometer. It is particularly used to measure the wind speed. It will measure the speed by using the pattern as shown here. This is the module which should be placed on the top of the building, then it will rotate as the speed over there. It is having one rotor part and one stator part. Stator part is having one reed switch and the rotor part is having magnet. Whenever this magnet comes on the reed switch, then the reed switch gets shorted and a high to low pulse is coming over here. This should be given as interrupt to the microcontroller. We will write the ISR in such a way that we will increment the variable inside the function. One of the timer is to be set in order to give the particular time, that is like 5 seconds or 10 seconds. For how many seconds we have to read those counts. Coming to the next sensor, this is wind vane, which is used to get the wind direction. It is having 8 sensors which are connected to the sensor which is used as a pull-up from the supply voltage. It is having 8 reed switches. This is the module which will use to get the wind direction. This is the direction panel. It is having one magnet. Whatever the reed switch will comes into the field of the magnet, then the reed switch will be closed. Reed switch will be closed. According to that, whatever the voltage generated over there is given as an input to the ADC. Then the ADC will convert the analog voltage which came from the board to the digital voltage. we have to write the program in such a way that according to the register values, the particular values of ADC will lies in between those two values. If it is lying over there, then we have to set some particular direction. This ends the WinWayne module. The setup is as shown here, and the output format is like